Have you ever stopped to wonder how your computer sends a file to the printer sitting right next to it, without ever touching the internet? It kind of feels like magic, right? But it's not. It's actually a pretty fascinating, super fast journey. So today, we're going to follow a piece of your data on that little trip across your local network, step by step.
Seriously, think about it. Your laptop and your printer, they're on the same Wi-Fi network. Or maybe they're plugged into the same little box. They're basically neighbors. But how do they actually talk to each other? That whole conversation happens in the blink of an eye, and we are going to pull it apart and see exactly how it works.
You know, the best way to wrap your head around this is to think about sending a regular old-fashioned letter. First, you've got the letter itself. That's your data, maybe a photo you want to print. Then you stick that letter inside an envelope. In our world, we call that a packet. And finally, you write the to and from addresses on it. That completely addressed, ready-to-go envelope, that's what we call a frame.
Now, you can't just have mail flying around willy-nilly, right? Any good postal service needs a set of rules to make sure everything gets where it's supposed to go. Well, in the world of computer networking, our official rulebook is called the OSI model. It's what makes sure all the different devices can communicate in a standardized way. And here it is, the famous 7-layer OSI model. I know. The first time you see this, you think, whoa, that looks complicated. But don't worry, don't freak out. For our local mail delivery, we only have to care about the 2 layers at the very bottom. Think of it as the physical roads and the local mail sorting office. Let's start at the very bottom. Layer 1, the physical layer. In our mail analogy, this is all the physical stuff. It's the roads the mail truck drives on, the truck itself, the actual paper the letter is on. In networking, this means your Ethernet cables, fiber optic lines, the radio waves for your Wi-Fi. It's the physical hardware that moves the electrical signals, the ones and zeros.
Okay, so right on top of that, you've got layer 2, the data link layer. This is like the local post office sorting room. Its whole job is to take that data, package it up correctly for the specific road it's about to travel on, and, this is the most important part, slap the local delivery address on it. This is exactly where our digital envelope, the Ethernet frame, gets built.
All right, you ready? Let's put on our digital postal worker hats for a minute and actually build one of these Ethernet frames from the ground up. We're going to see every single piece of information that gets added to make sure our photo makes it from the laptop to the printer.
So, at the very heart of it all, we have the payload. This is the packet that's holding your actual data. It's the letter we wrote, the photo you want to print. Everything else we're about to add is just protective packaging to get this important stuff to its destination safely.
The very first thing we tack on the front is something called a preamble and a start frame delimiter. Honestly, you can just think of this as a digital heads up. It's a special pattern of ones and zeros that basically yells at the printer's network card, hey, wake up, a message is about to arrive. This lets the printer get its internal clock perfectly in sync so it can read the incoming data without messing anything up.
Next up, we have literally the most important parts, the addresses. Just like on a real envelope, we add a destination address, that's our printer, and a source address, that's our laptop. This tells the local network exactly where this frame needs to go, and just as importantly, who it came from so the printer can send a reply back if it needs to.
After the addresses, we add what's called a type field. Think of this like a little note on the outside of the envelope that says, contains photos, or contains a contract. It tells the device that gets it what kind of packet is tucked inside, so it knows what program to give the data to. For instance, a little code in here might tell it, hey, this is an IPv4 packet.
And finally, at the very end of our frame, we add a little trailer. This is the frame check sequence, or FCS. It's basically a high-tech, tamper-proof seal. See, the laptop runs a quick math problem, a CRC, on the whole frame and sticks the answer here. When the printer gets the frame, it runs the exact same math problem. If the answers match, awesome, the data is perfect. If they don't, it means the frame got scrambled along the way, and it gets tossed right in the trash.
So we've been talking a lot about these local layer 2 addresses. But what are they really? What do they look like? Where do they even come from? Let's zoom in on that for a second.
Every single device that can connect to a network, I'm talking your phone, your laptop, your printer, your smart TV, each one has a totally unique physical address. It's called a MAC address, and it is always 48 bits long. Just think of it like a permanent, unchangeable serial number for networking.
So you might be wondering, how can you guarantee that every address is unique across billions and billions of devices? Well, it's actually a really clever 2-part system that gets assigned right at the factory. That's why it's sometimes called a burned-in address. The first half of the address identifies the company that made it, like Apple or Dell.
The second half is just a unique serial number that the company assigns. And with that simple system, no two devices on Earth should ever have the same MAC address.
Okay, so we've perfectly built our digital envelope. Our Ethernet frame is sealed, it's got a unique to address, a unique from address, it is ready to go. But who's the mail carrier? Who's actually going to read that address and deliver the mail on our local network?
Say hello to the network switch. If all your devices are like houses on a street, the switch is your friendly neighborhood post office. Its entire reason for existing is to look at the destination MAC address on every single frame it gets and then forward it only out the specific door or port where that device lives. It's way, way smarter than just shouting the message out to everyone on the street.
But how does the switch know where everybody lives? I mean, it doesn't come with a pre-programmed address book. Here's the really cool part. It learns as it goes. Every single time a frame comes in, the switch takes a quick peek at the source MAC address, the from address, and makes a little note to itself about which physical port that frame came from.
So, over time, just by quietly watching the traffic go by, the switch builds its own little map of the neighborhood. We call it a MAC address table. It's basically thinking, okay, I just saw a letter from address A come in on port 1. Got it. So next time I get a letter for address A, I know to send it straight out of port 1. It's a super simple but incredibly powerful way to learn.
And there you have it. That's how it works when the switch knows where to send the frame. It's a targeted, efficient, private delivery. But that leaves us with one last really important question to ponder. What does the switch do on its very first day, when its address book is completely empty? What happens when it gets a frame for a destination it has never ever seen before?